This video covers how to simplify square roots. So if I have something like the square root of 12, there's a way I can write that that's more simple. And it may not seem more simple, but we'll get into why it is a little later. The first thing I want to do is I want to factor this. What I'm looking for is if there are any perfect square factors. So for example, I could factor this as 3 times 4. 4 is a perfect square. 2 times 2 is 4. And that means that the square root of 4 will be 2. So if I rewrite this as 4 times 3 instead of 12, because 4 times 3 equals 12, and then break it into the square root of 4 times the square root of 3, this has a nice whole number answer of 2. And I get that this is 2 root 3. And of course there are other ways I could factor 12. I could, instead of seeing, oh, it's 2 times 6, and that's fine, because then I could go on and factor 6 as 3 times 2, and I would see a double factor here. And if I see a double factor that matches, I have a 2 here and a 2 here, then I know I have a 2 squared and that I have a perfect square. So if I'm not sure, I can factor it all the way down. But if I see a perfect square, I can also stop. Let's look at a more complicated example. Square root of 180. I start factoring this. The first thing I notice is that the digits add up to 9, so I know that it'll be divisible by 9 because that's a trick for 9s. So 9, and then I put it into my calculator and I see that it is 9 times 20, or maybe I can do that in my head. 9 is a perfect square, it's 3 times 3, so I'm going to stop. I could keep factoring, but I know I'm going to want to keep that one. 20 is the same as 4 times 5, and 4 is another perfect square, so I'm going to keep it. 5 is prime, so I can stop. I rewrite this as 9 times 4 times 5, which equals 180, so they're the same and I can rewrite it that way. Square root of 9 times the square root of 4 times the square root of 5. The square root of 9 is 3, because 3 times 3 is 9. Square root of 4 is 2, because 2 times 2 is 4. Square root of 5 is just some irrational number, because 5 is not a perfect square. So now I multiply 3 times 2, I get 6, and I get that this is 6 root 5. A word of caution, not every square root is simplifiable like this. If I have square root of 105, and I make a factor tree for it, I get, well, I know it's divisible by 5 because it ends in 5. And if I either know that one or put it into my calculator, I know that 5 times 20 is 100, so it has to be 21. And then 21 factors to 3 and 7. So this one has no repeating factors at all. It's got a 5, a 3, and a 7, and those are all prime, and none of them are the same. So this does not get any simpler than 105. So sometimes we can just factor out one perfect square, like in our example with the 12, where we could factor out a root 4 and get a 2. Sometimes we can factor out several, like with this 180. And sometimes we can't factor out any, like with this 105. And you just have to go through and see if you can factor out perfect squares.